Hi, everyone. Thanks for joining. We'll be getting started in about 3 minutes. All right, welcome everyone to today's webinar on near-miss information visualization tool in BIM for construction safety. My name is Jessica Bunting. For those of you not familiar with me already, I am the CPWR host and tech support for these events. So before we get started, I'm just going to go over a few quick things. First of all, if you have any technical problems throughout the entirety of the event with either the webinar system or the phone system, please contact me either through the chat and Q&A boxes or at jbunting@cpwr.com. You can just respond to any of the emails you've gotten pertaining to the event registration, and I will get those emails. We'll take some time at the end of the presentation to answer questions. Since your phones and microphones are muted through the system, you can type your questions into the Q&A or chat box at any time throughout the event, and I will read the questions out loud at the end. And finally, today's webinar will be recorded, and we will be sending out a PDF of the slides as well. So if you are interested in reviewing the information or sharing it with colleagues, I'll make it available to everyone via email after the event. Okay. Our presenter today is Dr. Eric Marks. Dr. Marks is an assistant professor in the Department of Civil Construction and Environmental Engineering at the University of Alabama. He is a registered professional engineer and conducts research in construction safety and innovation. And with that, Eric, I will hand it over to you. I believe you're muted. Just so you know. Eric?
Yes, are you there?
Okay, yeah, sorry, you were muted.
So can you hear me now?
Yes, you're coming through now.
Perfect, okay. Thanks for the introduction. As Jessica said, my name is Eric Marks from the University of Alabama, and today I've got about 15 slides, and I'm hoping to wrap it up within 20 minutes and then answer your questions. But I want to present to you some research that we're currently working on at the University of Alabama with support from CPWR in the area of near-miss information visualization and building information modeling. And so, as you may know, our construction OSHA total recordable incident rate in the past 3 or 4 years had kind of plateaued, and so it's not to that zero incident value that we strive for yet, and so there is area for improvement in terms of construction safety. So that kind of provides the overarching motivation for this work is to improve safety performance of the construction industry. So the research that I'm going to present to you today utilizes building information modeling, which is basically provides a platform for all types of communication and file sharing and information sharing for construction project stakeholders. And so on the slide, I picked some really good, actually in my opinion, really good safety research projects from academics that have kind of taken advantage of the communication platform of BIM to improve safety. And so these are applications that were created in BIM and can run on an existing BIM model. So things like a fall protection checker, safety scheduling, hazard ID, class detection, and the implementation of GIS information into BIM also helps with safety in terms of location tracking. So kind of the crux of our research, or kind of the driving motivation, is Heinrich's safety pyramid, and I'm sure that you've probably seen this before, but so I'll just review it pretty quickly. But basically, the idea is that we have these lagging indicators that of fatalities, injuries, and illnesses that OSHA requires that we measure and benchmark our safety performance. But Heinrich basically theorizes that there are a whole host of these leading indicators, including near misses and at-risk behavior, that are at a higher ratio than our lagging indicators. And so to kind of say that simply, if you have a fatality or an injury or illness, the theory is that there's some trail of near misses and at-risk behavior that occurred before this lagging indicator occurred. And so the idea of the pyramid is that if we can find this diamond in the rough in terms of leading indicators, near-miss reporting and at-risk behavior, hazard ID, and these kinds of things, these proactive safety techniques, that we can maybe mitigate some of these lagging indicators that occur. With that said, I know in the past 1 or 2 years, the safety pyramid has been kind of a hot button topic for research and industry professionals. There's been a few projects that have taken real life data and compared the ratios of what actually happened versus what the pyramid says, and suggest that the ratios are maybe off, or maybe that the pyramid is more tall and slender, or maybe it's a rectangle. And so I don't know the exact ratios or anything of that nature, but I do know that if we can collect these leading indicators, then we can potentially mitigate hazards on construction sites before we have to go through the process of a lagging indicator occurring. And so what I want to focus in on today is near-miss data collection, and then how we analyze and visualize that information. We collect near misses through safety audits, management walkthroughs, and then for some companies, if you have a robust near-miss reporting system, there is a system for all employees basically to report near misses and kind of use that data set as a way to mitigate hazards or to identify potential hazardous areas before a lagging indicator occurs. So I was on a research project funded through the Construction Industry Institute a few years ago. Our research team had about 30 industry professionals, and we spent 3 8-hour work days, I guess for lack of a better word, arguing of what the definition of a near miss should be. And so kind of the distinguishing point there was, do we include unsafe conditions or not? And I work a lot with construction safety managers, and I found that they're very passionate about how we define certain elements of a safety program specific to their company. And that makes total sense, because you want everyone to understand what category of each event reported should be and how you should use that information. And so my personal opinion, and I found this kind of consistent throughout the industry, is near misses should include unplanned events and unsafe conditions. And so that unsafe condition could, an example of that could be if you have some scaffolding and you had a missing toe board, you don't need a hammer hanging off the edge, or you don't need some falling piece of equipment. But if that unsafe condition exists, that can be categorized as a near miss. So this is a near miss reporting card. I borrowed this from a really well-known oil and gas company that has a very robust near miss reporting program. And basically how they report near misses is they set up near miss reporting workstations throughout their construction site. They have pens or pencils and these cards, and they ask workers to fill out these cards based on near misses that they observe throughout their workday. And so that's one entry point, data entry point. At the end of the day or end of the work week, the supervisors will gather all these cards and take them into some office, and usually through Excel spreadsheet or Microsoft Access or some database program, they will manually input the information. So that's kind of a second data input entry. And then they have to share these individual documents with different stakeholders or interested people across the company. And so while this system works, this current system, and this is the system that I see most common throughout construction companies that have near miss reporting programs, while it works, it requires a pretty daunting task of inputting these near miss reports as they were another safety category of safety data into the computer and going through that process again. And so kind of the value of our research is that we enable visualization of the safety data, but we also cut out one data point entry basically and kind of optimize that process to some degree. So this is a flow chart that shows our near miss information visualization process. And so the red at the top shows data input. That can either be user manual input, that can be from an iPad of a supervisor, that you can even go back to the traditional system where you take the near miss reporting cards and input that data into the database, or you can have an existing external database that will link to our visualization tool. And so if you move down to the blue, you see data manipulation within BIM. So once that data is collected, we can populate a BIM-enabled near-miss database. And so what's different from that in Excel and Access is that this database is connected to a building information model. And so anyone that has access to this model can automatically receive up-to-date near-miss information and analysis and things like that versus having to email out updated drafts of your database throughout the project duration. With this database, you can also query near-miss data for different types of analysis. You can rank the severity and only look at high severe incidents. You can look at different people, different times of day, all of these different parameters you can analyze based on this database that we're using. And then the output would be you can export the near misses to some external spreadsheet file. And kind of the biggest output is you can visualize this near-miss safety information through a BIM model using spatial location information. And I'll show you how that works in a couple of slides. This is a reporting database interface that we created through a previous project with the Construction Industry Institute. And what we did as part of this research is basically use the same input database in our near-miss visualization tool. So you can see things like near-miss ID, you can see the severity, you can see the identification, classification, task associated. And then as you move down the interface, you can see different reviewers of the dates that they reviewed the document, and you can see a picture to the far right. And so this is based on a lot of surveys of construction safety personnel in terms of what information is quality and effective for us to capture when we have a near-miss report. And it's also an active record. You can see that you can date when the first review happened, when the second review happened. So it kind of acts very similar to what a BIM model acts in terms of a construction project, that it's an active record. You can go in, you can modify, you can change different components of the database, and it's immediately updated to all users of that BIM. This is a screenshot of our user interface. It's pretty simple. It's a four-step process to create and analyze a near-miss report. So you can see across the top, there's a near-miss tab. That's our application that we created, and we're using Revit as our BIM software for this, mostly because it's free to the students here. It's widely used in the construction industry. And kind of the main reason is it has the open API, the application programming interface, which basically allows us to go in generate new programming code and come up with new applications similar to how you would do on your smartphone with an application, if you were creating a new one or something like that. So you can see step 1 is to access the tab. Step 2 is to create to click on the create icon to create a new near-miss data record. Step 3 is to input all the information that I showed you on the previous database input slide. And step 4 is all about analysis or queries. So you can query by severity, you can query by ID, or you can query by basically any of the input parameters for the near-miss record. So this is a Revit model of one of our current buildings on campus that's under renovation. We created dummy near-miss accounts just to see if these would actually populate in the model. And so this is the red dot is the near-miss record within the software, and so you can see that the location information is kind of what ties all this database information together. You can view it in 3D or 2D. You can click on that red dot, and the database structure will come up and give you all the information about that specific near miss. So I have a video now I'd like to show you. I'll talk through what's going on in the video, but this is our actual tool within a Revit model being used and kind of demonstrating the different components of that tool as it goes. So the video has started. You can see that we're switching between different tabs at the top. We've clicked on the near miss tab, and now we're zooming in to see what near misses have already been reported on this structure. Each of the yellow dots is a reported near miss, and you can see there's 2 near misses reported on this leading edge. So maybe there wasn't fall protection. Maybe someone not wearing PPE was found, and that was defined as a near miss. You just saw the third yellow dot come. That was the created near miss. We've added in a new near miss record, and that's in our 3-dimensional view. You can also switch to the 2-dimensional view and insert that near miss record as well. And so now that the near miss location has been identified, you can see the table to the far left. It says properties. And you basically, as an input user, you would go through each of these properties and input the information. So you can see the time is being entered there as the date. You can also put the specific time of day. The task associated, we decided it would be critical severity. You can see the resolution reviewer. And basically, as you're inputting this information, you would go through each of these properties and input as much information about the near miss as you could. Once this is saved, it can be viewed by anyone who has access to the BIM model, or anyone that you approve to view the safety data could see this, could make modifications, and could add information to this specific record. One of the things that we found, it's at the very bottom of the property list, is construction managers or safety managers specifically, have asked that we enable users to upload photos, and so that allows for someone that's not familiar with the near miss to actually see the photo, which is shown now in the picture slide. This is the database with all the information that was just input, but you can basically view the picture of the near miss and kind of get a feel of what's going on at that specific location. So we've shown the interface. Now we're assigning some severity to the near miss. We just did a query for the severity, and you can see that there's only one critical severity, which marked in red, and that's the one that we just input into the database. We can also query by near miss ID, and our ID was 123456. So if we search for this near miss ID, we basically get the information that we just input into the database. And so you can basically query through all different types of parameters of the near miss to kind of get an idea of what location a lot of near misses are occurring, or what time of day a lot of near misses are occurring, or any information that you input in the near miss database. You can query and kind of gather like events from that. So this is a screenshot of what you just saw on the video, but it's expanded a little bit. You can search near misses by their unique identification number. You can query by severity. You can query by location, by time of day, any of those parameters. After we created this tool, we found several active construction projects that had pretty robust near-miss reporting programs. We asked to borrow the data for research purposes, and we populated the BIM model with these near-miss reports to see if this tool could actually work in an active construction environment. We also assembled a safety expert review panel of construction safety managers that had 10 or more years of experience in construction safety management. We asked them several questions about the tool. We demonstrated the tool to them, and we allowed them to manipulate the tool on their own computers just to kind of get a feel of how it works. They provided their responses based on a Likert scale, and so number 1 was strongly disagree, all the way through number 5 was strongly agree. And so we asked questions like, do you feel there's a need to integrate safety into BIM? Is it a good idea to visualize safety information? Is the tool easy to use? All the way to, do you feel like this tool would improve safety management? And so this survey is largely subjective, but we really wanted to get that input back from people that would one day maybe actually use the tool and implement it into their safety program as part of one of their construction projects. And so we received a maximum score for all the issues from one of the 10 participants. What we were really interested in is to look at the minimum score, and we found that we had 2 disagrees on our responses. Both of those responses were from the same person, and what we found out after doing the survey is that this person, their company used the BIM model for design, but they basically printed out all of the documents and had paper-based blueprints during actual construction. And so they didn't implement the BIM for the construction phase of the project. And so as he was answering these questions, he was also including the learning curve for teaching people, for teaching managers how to use BIM software basically as part of this tool. And so with that said, those were his responses, but that's kind of behind what we received in terms of those responses. So just to kind of conclude the research and what we've done, we found that we can analyze, we can visualize, and through that visualization we can disseminate learned information from near-miss reporting. We found that safety managers can visualize specific locations where a high frequency of near misses are occurring. We found that safety professionals and project management people can visualize near-miss reports. And we found through doing the survey that I just showed you that experienced construction managers to some degree found value in visualizing these near-miss reports. And so I would like to acknowledge my graduate student, Xu Xin. He did a lot of the programming on this project and really helped to foster the idea, administer the surveys, and so he was a large part to this project, along with support from CPWR. And with that said, I would be happy to answer any questions you may have about our tool or our research or any other comments that you may have.
Great, thanks so much for that, Eric. We do have one question here about the expense related to using BIM software. Since it's expensive, are there any options or do you have any recommendations for small construction companies, how they could achieve something like this?
That's a great question. The actual tool that we created would be available for free, obviously, but kind of the big hurdle is purchasing BIM software. And so I don't know if they give. I know they give rates to. They give discounted rates to students and academic and those kinds of things. The same may be true for small construction companies. If you're willing to participate with them and start using their software, they may give discounted rates, but they may not as well. I'm not sure how that would work, but that would be one barrier to implementing this type of research would be that initial cost to the software.
Okay. The next question is, can workers input data? Would they have access to computers to do so?
So that's a very good question, and my hope or my dream, I guess, would be that one day we could get to that point where supervisors maybe have smartphones or iPads on site, and they could input this information as they report in near misses. I've only seen this a few places, but I've seen a few larger construction companies, rather than have pencil and paper at their near-miss reporting stations, they have iPads set up. And so they ask workers, as they witness or observe a near miss, they would go to this iPad and through a very simple interface start to enter information about that specific incident. So if you were able to do that, I know that adds cost on as well, and there's a learning curve for that as well. But if you were able to get to that point, you would eliminate several areas of or entry points for data. If it could immediately be uploaded to the BIM model, that would be the best of all the options, I would think.
All right, thank you. Let's see. Next question is, have you assessed the usefulness of potential outcomes for the near miss as an expression of risk severity? Exxon's mining the diamond is given as an example.
Oh, yeah, that's a great question, and that's when talking about near misses, and when I say that we assign a severity, that I usually get a lot of questions about that. And I'm familiar with Exxon's program. I think it's great. The severity on this tool, we simply assign it. It's a very subjective measure, just so you can differentiate between high, medium, and low severity. And so I'm not sure what Exxon's severity rankings are. I think there's more than 3, but I could be wrong. I'm not sure. But it's not so much of what the actual severity is, but it's really beneficial to differentiate between different severity levels. And so I haven't talked to any. When you say risk management, I think about insurance companies. I work with them a lot, and they're very specialized in assessing risk and kind of understanding what's going on. And some of the larger insurance companies I've talked to, one of the drawbacks I hear from safety managers is that it may, if we have this additional data set of safety information, we may have to report that to the insurance company. And every insurance company or representative that I've talked to is very excited to see construction companies start to collect proactive safety data and even suggest that the rates could go down because you would be potentially mitigating risk before an actual lagging indicator occurred. But I think that would be a really good next step to this, is to really dig into the severity and understand how that impacts our safety performance.
Yeah, great. Okay, thanks, Eric. The next question is, can unsafe conditions found during the audit be added to the location where they're found?
Can you repeat that? I'm sorry.
Can unsafe conditions that are discovered during the audit be added to the locations in the system?
Oh, absolutely. Yes, they can. So those can be, if you have, a lot of people categorize unsafe conditions as hazard ID, and most companies have a really robust job site hazard analysis program. And so any of that information, if it's in some kind of spreadsheet form, it can be uploaded all at one time into the near-miss database. If you're talking about ongoing unsafe conditions that you witness, they can be individually reported as near misses, and they'll populate with all the other data. Okay.
Has this research already been published? I believe it has. Is that correct?
It has, yeah. There's an article in the Journal of Construction Engineering and Management that's published, and we submitted a final report to CPWR as well.
Yes, and I believe that is on our website. So I'll send out the link to that when I send out the slides and the recording of this webinar. Okay, and let's see. The next question is, perhaps I missed this, but is there a way to input the intervention used to prevent future near misses in the database?
Oh, that's a great one. There's not a specific parameter for that. We could that would be actually a really good thing to include. I think that would kind of help for future improvement. Absolutely. But you can. There's a huge comment section, and then there's a lot of input information with regards to cause identification, root cause analysis, and resolution determined by the team, investigative team. And so all of those areas, I think you could specify a different practice or different behavior or different policy maybe to hopefully stop this specific type of near miss from reoccurring.
Okay. Our next question is, what type of time commitment is required for the initial creation of a typical building on site, and what type of time requirement would exist for usage and upkeep?
That's a great one. That would largely depend on if you had an existing BIM model, and I'm going to assume the question that you do. If you don't, then you would obviously have to go through the design process of that model. I will say that my students, they're pretty fluent in Revit and BIM modeling, and so we can create just a structural frame of a model within maybe like an hour of an actual building. If you have all the information and the plans, or if you have a picture of the building, it's pretty easy to do. And if you want the whole details, that takes much longer, obviously. But so if you already have the model, it's very simply just download the application into your specific BIM software. It should populate, and then the rest of the time commitment would be downloading. If you have some existing near-miss database, you would want to upload that into the model, or if you have individual reports, starting to put those into the database. That would be the major time commitment there. But with all that said, it's not such a significant time commitment, I would say, in terms of what you get out of on the back end of being able to visualize the near misses and have all that information for anyone who wants to access the model.
Okay, and we have one more question. How many companies are implementing this visualization tool at this time?
That's a great question. Yeah, so it's actually brand new. So we have companies that we did some active test trials on, and the last I followed up with them, they were still using the tool, but there hasn't been any company to implement the tool as of yet. Our facilities group here at the University of Alabama, they do most of their design and construction work in BIM, and so they have shown some interest in implementing the tool, and we're conducting meetings to kind of talk about that. But the short answer is no. There's no company that's fully adopted our tool as of yet.
Okay. Well, we are done with the questions. If anyone has anything they didn't get to ask or that wasn't answered, feel free to just email me at any time after the event. And thank you, Eric, so much for a really interesting presentation.
Absolutely. Thank you for the opportunity, and thanks for your participation as well.
Great. Take care.
Bye.